And to finish up function notation, we want to think about how does this relate to a way of visually seeing functions? Namely, how does this relate to graphs? All right? To see that, we're going to take intermediate step is we're going to turn this function into a series of points. It won't be all of them, but it'll be enough to give us an idea. So I'll pick some easier numbers. Maybe I want to say, okay, what happens if I plug in 0? I'll have 0, comma, that'd be my input. My output would be, what do I get if I plug in 0 to g? Namely, what is g of 0? Okay, let's practice that. I plug in 0, I get 2 times 0, which is 0. Add 3, and I get 3. So that really is 0, comma 3. Let's get a few more of these. If I plug in 1, give me 1, comma g of 1. Okay, let's find g of 1. I plug in 1 up here. 2 times 1 is 2, plus 3 is 5. So g of 1 is 5. Okay, let's do one more. If I plug in 2, my output would be g of 2. To evaluate g of 2, I plug in 2 for x. Like 2 times 2 is 4. 4 plus 3 is 7. And so my output is 7. Okay? Now I've got 3 points here. And if I have a point, well, it's pretty easy to turn those into the graph. So I set up some axes. X is the horizontal, Y is the vertical. I'm going to add some tick marks here. I could tick out down here and to the left, but right now I don't have any negatives, so I'm not going to worry about that. So 0, 3, 0 is the point right there. We get 1, up 5, and 2, and up 7. Right? They might recognize this from algebra. You may recognize the equation as a linear equation. That's because we only have like basically x's. We don't have any squareds or cubes or anything weird like that. It's just some unknown x multiplied by a number and then adding a number. So linear means our graph is going to look like a line. So we end up with a graph that looks something like that. Right? So each one of these inputs to this is actually output there. So right here, is actually the point right here, 2, comma g of 2. And we know if we evaluate g of 2, we get 7, and that'd be another way of describing that point, 2, comma 7. Right. You can also go backwards here. If you're given a graph, and this is g, and you're saying, okay, well, what is, and they ask you, like, hey, we have 1, comma something, we know this is the function g, we could look on the graph and say, okay, it's 1, comma 5. It must be 5 right there. Okay. So to sum up function notation, it's very similar to just writing an equation that's y equals, but it has a few advantages. One, that it gives us names of functions, which help when we have a lot of different equations. And it also stresses that functions really deal with input and output. It's just a y equals equation. You just see kind of a balance. You see a couple of variables. But with function notation, like we have up here, you say, okay, we have a function named g that has an input of x. The way you get the output is by substituting in for x and evaluating this expression. And we notate the output of this by g of whatever you input. So here g of x, but it might be things like this, like g of 2 would say, what's the output of the function g if you input 2?